In this video, we are going to go over section 2.7, which is marginal analysis in business and economics. The goal of this section is to solve problems involving marginal functions in the field of business and economics. And if you guys already seen the PowerPoints that is uploaded, there were a lot of definitions and then terms. So this notes kind of put it into a one page where they list out all those functions and how to take or how to find those marginal cost function or average cost function or marginal average cost function. So when we say total cost, there's a cost when something is produced. You have to think about cost and then how much does it cost? How much do I make? But that's not a pure profit. So pure profit is the cost minus the revenue. So these are very simple terms that we use every day. Total cost, total revenue, and total profit. We have some kind of a cost happening and we get some money coming in, but that money that you make technically is not a pure profit because you have already paid something to make a cost. So total profit will be revenue take away the cost. Now, when we use word marginal, that's when you start taking the derivative. So marginal cost means whatever the cost function, you take the derivative. So I associate the word marginal with term derivative. So anytime that I see a marginal, oh, that's derivative function. So marginal cost means, oh, take the derivative of a cost function. Marginal revenue means take the derivative of revenue function. Marginal profit means take the derivative of a profit function. So you see all those primes. C prime of x, R prime of x, and then R prime of x minus C prime of x. So that's kind of easy way to organize. Now, average, same thing. You have this average cost. How much on average does it cost to make something? Average revenue and average profit. And we use this bar. So C bar, R bar, P bar, and that's very simple. Think about this. When you are trying to find the average of something, what do? You take this total function, total C of x, and divide it by the number of units. So let's say I want to know the average exam score. You add up all those average, the total, and divide by number of exam. So you have that C of x divided by x. Total divided by the number of units. Total profit divided by number of units. So anything average involved, we start having these fractional part. And simple again, when you see the marginal average cost, all you have to do is take the derivative of this function. Marginal again means derivative, so you would take the average revenue and take the derivative. And then marginal average profit, you take the average profit and then what? Take the derivative. So marginal associate with the word derivative. Okay, so 1 through 10 is just all the exercise of getting used to the terms. So I have the cost function and then the revenue function given, cost function, and then the revenue function. And then we are going, so these two are given, cost, total cost, and revenue. And then using those two, we are going to find rest of them. Marginal cost function, average cost, marginal average, and so on. All you have to do is just follow that definition. So let's begin with number 1. I see the marginal. Marginal means derivative. What are we taking the derivative of? A cost function. So That's just find C prime of X. That's what it means. Right there. Marginal derivative of what? Cost function. Well, I already know the cost function right there, C of X. So that's term by term. So 600, 0. Negative 4x means negative 4. 2 comes down, multiply with 6. So I'm going to get 0.0012x. Just rewriting more nicely, I'm gonna have negative 4 plus 0.0012x. That's it. All right, keep going. Average cost function. Okay, I have a cost function, but we are gonna average them. So we are really finding C bar. So total divided by number of units. That's what average mean. Okay, well, I know the total function, that's 600 minus 4x right there, plus 0.00066 squared all over x. And you can leave it like this, or you can even simplify further. I'm gonna separate term by term. So this is 600 over x minus 4x over x, 0.00066 squared over x. And then simplifying, I cannot simplify anything here, so 600 over x cancels out, minus 4. One of the x cancels out, so I have 0.0006 x as a final answer. That's your C bar. So it's not too bad, it's just a lot of terms. But remember, look for the keyword, cost function. Oh, but then what are we doing? Marginal, so that means take the derivative. Average, think of what you do. How do you find the average of something? Total divided by number of units. That's why you see that fraction part. But if I add word marginal average cost, then all I have to do is take the average and then take one more step and find the derivative. So let's do a bunch of practice. Oh, there comes word. We have a cost, CX, but average means C bar, and then marginal means find C prime of bar. So that's what we want to do, C prime bar. Okay, well, we found the average cost function already here on part 2. That was C bar was 600 over x minus 4 plus 0.0006x from number 2. However, I need to take marginal. Remember, this is our final goal, so all I have to do is take the derivative of this function, which is pretty easy. I'm going to rewrite this so it's more friendly. This 600 over x can be rewritten as 600x to the negative 1 minus 4 plus 0.0006x. So this will be negative 600 x to the, bring down the subtract by 1, so negative 2. Negative 4 is a constant, so it disappears, 0. This last term, 1 comes down, subtract 1, that's a 0. So I have 0.0006. So my final answer, you can leave it like this, or if you want to put it into a positive exponent, that will be negative 600 over x plus 0.0006. Done. Let's try number 4. Let's look at the keyword, revenue function. Revenue function means R of x, but there's a keyword, marginal. So that means find R prime x. Okay, that's it. Look for keyword and then look for what else there are. Look for those adjective term, marginal. So I have Rx already given. So marginal revenue, again, it's right over here. Just take the derivative. Okay, Rx is given as, from previous page, as 1000 x minus 20 x squared. So the derivative will be 1000 minus, okay, 20 times 2, which is 40, x subtract 1, negative 40x. Okay, again, more drill, more practice, getting used to the terms. Look for the key term. Oh, revenue. That's Rx. What are we doing with the revenue? Take the average. Oh, so I'm gonna need to find R bar X, which is R of X divided by the number of units. Average, total divided by number of units. Well, R of X from earlier, we saw that it was 1000x minus 20x squared divided by x, separating the term and then simplifying. The 1000, the x's cancels out, and then this x cancels out. So in other words, let me not skip a step. So 1000x over x minus 20x squared over x. So x cancels out 1000, and then one of the x cancels out, so we have 20x. Okay. Moving on. Now what are we gonna do? We got average revenue function. That was from part B. What are we gonna do? Marginal means take the derivative. So all we have to do is take the derivative of what we just found. So that means 1000. I'm gonna take derivative of this part over here. 1000 disappear. Negative 20x is just negative 20. Okay. So I'll just rewrite it one more time. We already know the average revenue function, R bar X from number 5 was 1000 minus 20x. Marginal means take the derivative of that, so which is just negative 20. Done. So the terms, I mean, it looks like a lot of terms, but it's not too bad. You can see that, oh, I just have to take the average or take the derivative. Okay. Profit function. What is profit? Profit is revenue minus the cost. So let's first find the profit function. Revenue minus cost. Revenue from the earlier highlighted in blue and then highlighted in yellow for cost. I'm just gonna copy down. Revenue was 1000x minus 20x squared. Cost function was 600 minus 4x plus 0.0006x squared. These were given, right? The cost function was yellow function, and then revenue was blue function. So let's subtract that. So P of X is, well, if I distribute all this, you have 1000x minus 20x squared minus 600 plus negative with the negative 4x negative with a negative plus 0.00066 squared. And then I have two terms that I can add, x squared. So negative 20 at 0.00066 squared, I'm getting, I'm sorry, this was a plus. So negative with the positive is a negative. My mistake. Just misread my writing. So that will be negative 20 point. So P of x, I ran out of space, so I'll just use this one here. P of x will be combining these two, negative 20.00066 squared, 1000x plus 4x, 1000 4x, and last term minus 600. So that will be my final answer for number 7. Right there. Now we know what profit function is. What are we gonna do? Marginal. That means take the derivative. Marginal means take the derivative. Easy. So what we got here, we just have to take let me just copy and paste. Copy. We know what profit function is. Right here, we just found it. What are we gonna do with this? Number 8 is asking to take the derivative, p prime x. So let's do that term by term. 2 goes down, multiplies with this, so that's gonna make negative 40.0012x. Subtract 1, that will be just 1, plus 1004, and the 600 disappear. So this will be my final answer. Number 9, what are we gonna do? We have the profit, but take the average. So that is P bar X, which is profit, the total profit divided by number of units. So profit function right there, negative 20.0006 x squared plus 1004x minus 600 divided by x. Let's do some algebra, separate the fraction and simplify. So negative 20.0006 x squared over x plus 1, oh, that's 1004. 1004x over x minus 600 over x. So reducing, I have negative 20.0006 x plus 1004 minus 600 over x as the final answer. That will be my P bar x. All right, one more term. I bet it's gonna be marginal average profit function. Yes. So we got all the way up to this. That was P bar x. Marginal means take the derivative. So we need to find the derivative of P bar. What was P bar? From previous page, that was your P bar x. So copying down, negative 20.0006x plus 1004. And I'm just going to rewrite that as negative 1. So it's easy to take the derivative. Okay. So we have this first term, that's 1, bring down, negative 20.0006. The x to the 0 power disappear because it's 1. So it will be, the first term is just negative 20.006. I keep putting this, it is 1004. But 1004 is a constant term, disappears. The last one, negative with negative makes a positive 600. Subtract by 1, so it will be x to the negative 2. Or you can rewrite that using positive exponent as negative 20.0006 plus 600 over x squared. Done. So we went very fast, but also at the same time, these terms, 10 definitions are not too bad. You just look for the keyword and look for the adjective, and that will tell you what to do. Average or take the derivative. Okay? So hopefully doing these 10 exercise and looking for keyword and key terms, you feel a little bit better with all these terms. And I went through 1 through 10, so your related homework problem also is number 2 through 9, and they may go kind of like out of order. Oh, I give you cost function, find the marginal average cost. So those are your exercise problems. Now the last half, I like to go over these two application problem. Okay, so we practice terms and then knowing how to find the function for each term. Now we are going to use the term and then apply to a application problem. So let's take a look at number 11. So we are given total cost function, C of x, as 10,000 plus 15x. You see the word average cost. So that means C bar x. If 300 are produced. So in other words, part A, that's like saying find C bar x when x is 300. Okay? Find the marginal average cost. Marginal means take the derivative of what? Average cost, C bar x, but you take the derivative. When what? X is 100. At 300. So again, part B is very similar too. Part B is asking C bar prime when x is 300. So again, similarly what we did with 1 through 10, you're just going to look for keyword and then substitute those keyword into an equation. And then finally, part C is just asking, use part A and B to estimate average cost per unit if 301 units are produced. So let's begin with part A. I need to find C. I'll find C x bar first and then substitute x equal to 300. So C bar x means C of x divided by x. So C of x is 10,000 plus 15x divided by x. So it will be 10,000 x plus 15. What do we do? Plug it in 300. So plug it in 300 here. 10,000 divided by 300 plus 15. So let's see. 10,000 divided by 300 plus 15 I get final answer as, and let's just being consistent, it's a dollars. So it's 48.3 repeated, so it will be $48.33. Okay. Part B. Find the marginal average cost at a production level of 300 units and interpret the result. All right, so that is C bar prime and X being 300. So we have C bar X right here. So let's first take the marginal, means derivative of that function. So C bar X is 1000 X 10,000 X to the negative 1 plus 15. So C prime of X bar will be negative 10,000 X subtract 1, so negative 2, and then 15 disappear. And what are we going to do? All we have to do now is just plug it in. 300. So negative 10,000, 300 to the negative 2. So let me put that in the calculator. I'm getting, again, it's a money, so I'm going to round it to the 2 decimal place, negative 0.11. Okay, so what does this mean? Negative means losing money. So this means that the average cost is decreasing by 0.11 per unit produced. Okay, so which is not good, losing. So part C is, I got A and B. They want you to use part A and B to estimate average cost per unit if 301 units are produced. We use 300, so what if we produce one more? Well, average cost per unit for the 301 unit will be this one, 48.33, but one more unit, I'm gonna lose, right? That means decrease by 0.11 per unit. So if I make one more unit, from $48.33, I'm gonna lose another 11 cents. So I'm going to end up having $48.33 subtract 0.11. So you don't have to go through a whole thing of finding 301. You can see that these two, this was 300 production, number of 300 production. Creating one more per unit means each unit. So I need to just subtract those two. So let me write it out. The average cost per unit for 301st unit would be $48.33 minus 0.11, which is $48.22. Okay? All right, last problem, and this is number 13 on your homework problems. Very similar. I just modified the function a little bit. So we have these two functions given, cost and revenue, and it's asking for 4 different parts. Let's begin with part A. find the value of x where r of x is a horizontal tangent line. We talked about horizontal tangent line earlier in 2.5. Earlier section, we talked about that horizontal tangent line means slope function. In other words, first derivative has a value 0. So that's from section 2.5. So that's what we are going to do in part A. So part A, I want to find where r prime of x is equal to 0. That means I need to first take the derivative of this function. So that means r prime is 40x. First term is 40. Second term brings down, I have 0.2x. 2 times 0.1, subtract by 1. And I want to set that equal to 0 and see where that x is. So I'm going to be subtracting 40. Negative 0.2x equal negative 40 divided by 0.2 divided by negative 0.2. So x is equal to, I get 200. So when x value is 200, in other words, 200 units are cell, you are having that horizontal tangent, the vertex, in other words, max value. Because this is facing down parabola. So in 2.5 video, I show you how you use the calculator to check. So this is the max parabola. So that will be the max production. How many? 200. Part B, find the profit function. From the definition, profit is Rx minus Cx. So we just have to subtract between the two. P of x is Rx minus Cx. R of x is 40x minus 0.1x squared. And then subtract 5x plus 2,340. So just distributing the negative 40x minus 0.1x squared minus 5x minus 2,340. So rewriting negative 0.1x squared, 40x subtract 5x, negative 35, positive 35x minus 2,340. And that will be my profit function. Okay. So part C, part C is saying find the value of x where P of x is a horizontal tangent line. So this time the problem is asking find P prime of x where it's equal to 0 and I need to find the x value. All right. So that's easy. I have this function here. So if I take the derivative of each term, first term, 2 comes down with a negative 0.1. I'm going to have, let's see, 0.1 times 2. I have negative 0.2x. This part is plus 35. Last term is just 0. Because it's constant. Okay, so I have to set that equal to 0 and then find out where the x value, because it's asking you to find x. Subtract 35 divided by 0.2. X is equal to 35 divided by 0.2. 175. I'm getting x equal to 175. Okay. Part D is graphing the function and then find the break-even point. And then also it's asking you to find the x-intercept of the graph of p of x. So I already know what C, R, and Px. So I'm going to use these three equations right here. Use the calculator to graph and then set that x value between 0 to 1000 and see where they have a break-even point. And also find, there's another part, two parts, find break-even and then find x-intercept of the graph. Okay, so let's pull out the calculator. We'll use this. Let me start with the C of x. C of x was 5x plus 2,340. This black line will represent my R of x, which is 40x minus 0.1x squared. And then my red one will represent the profit function, which is 35x minus 0.1x squared minus 2,340. Okay, but I think I put on the notes backward, like highest power, but it's commutative property. So let's plug it in. And I'm going to adjust the window. They said 0. Oops. They said 0 to 1000. Right. Okay. And then y, I'll just put by 100. So we are not increasing by 10. So y minimum, I'm just gonna go, I don't know, this one you just have to play around. I'm looking at my function, so I'm just gonna go to, I don't know, negative 100 all the way up to 3000, counting by 100. They didn't give y value, so I just pick a random number and see what I have. So I get this happening here, right? And you can kind of see my graph is not shown. I have to adjust my window to see what's happening up there. So I'm gonna go ahead and adjust my window and then to even go higher. Let's say 5,000. Okay, oh, and that looks good. So I'm going to screenshot this one. So I have a picture. There are two parts that's kind of connecting. Remember, this over here, let me go back and then make a note here. And then this is what we saw. This is part D, continuing. This is your C of x function. This was your R of x, the black one, and then the red one was P of x. That's what I use. And if you look at where R of x and C of x, there are 2 points. This point here and this point here. And these 2 points happens, and I'm going to use the calculator to get where that x value happens. Okay, and that will be your break-even point where they are equal to each other. That means intersection points. So break-even point is when C of x and then R of x are equal to each other. And um, you can go to second calc and then press number 5 to intersect and then get that from here. You know what? Let's just use algebra and then confirm with the graphing calculator. My graphing calculator is an iPad one, it's not pretty straightforward with the function, but we can do algebra. All we have to do is set those two equations each other. We know C of x and we know R of x. C of x is 5x plus 2,340, and then I'm gonna set that equal to this one over here. So we have C of x, 5x plus 2340, R of x, 40x minus 0.1x squared. And I'm gonna put everything on one side, set it equal to 0 to solve for x. So on the left hand side, I have 0. On the right hand side, I'm gonna write it in order, 0.1x. 40x minus 5x, that's gonna be plus 35x minus 2,340. Okay, and then I do not like this one. The trick is I can multiply the whole entire equation by 10 to get rid of the decimal. Then I can have a lot easier function, x squared, and then 350x, and then 23400. And then this is a quadratic, and then recall from algebra factoring. If you're still not sure about factoring polynomial, please review some algebra. But this factor as x minus 90 and then x minus 260. So using the zero product property, I do find the two places where when x equal 90 and when x equal 260. So this must be when x equal 90 and this must be when x equal 260. So let's check. So first one, I'm gonna press when x equal 90. Let's see if there's an intersection point. Yep, that hits blue and then green, black. And the y value associated that is 2,790. So I'm gonna use that one. So 90, 2,790. And let's use a calculator to confirm. The x value was 260. What's my y value when I trace that? That will be right there too. You see the intersection point of blue and then black, and it is 3,640. Okay? So these are my two break even points. 90, 2,790, and then 260, 3,640. Last part, ask for x-intercept. That's easy. X-intercept, you also see that on the graph. There's 2 points here, right? And we'll use a calculator to see those 2 points are correct. But using algebra, that's how do you find that y-intercept? Set x equals 0. P of x function. What was our P of x? Right over here. P of x negative 0.1x squared plus 35x minus 2,340 equal to 0. Similarly, I'm just going to multiply by 100. So I'm going to have, I'm going to multiply by negative 10 to make it positive, so it will be negative 0.1 times negative 10. I'm gonna have x squared minus 350x plus 23400 equals 0. And then you see that it's like almost exactly like this one, right? So we can see that this is going to end up being exactly the same. I'm going to have, which is the same as above. So my x-intercept equals 90 and also 260. And you can see graphically they do line up here. So that matches up. All right, that's it for 2.7, and then I will see you in the next video.